Hi, my name is Rick. Welcome to this module about language and literacy. This module is about 12 to 15 minutes long, and let's just talk about terminology for a second. I'm going to be talking about speech on the one hand. That's what I mean when I say language. Also, sign language is another form of language that I want to include under that label. Reading and writing, on the other hand, are what I mean when I say literacy. Let's talk about some outcomes for this module. By the end of this module, I want you to be able to describe how language is an adaptation that's unique to humans. I want you to be able to explain that as an adaptation, it's part of our biology. And I want you to be able to differentiate the ways in which the brain processes speech and script. The readings for this module are Steven Pinker, The Language Instinct, Chapter 10, Language Organs and Grammar Genes, and also Diane McGinnis, Why Our Children Can't Read and What We Can Do About It, Section 1, that's chapters 1 through 5. So let's start with the big picture. Humans evolved from a shared ancestor with chimps and bonobos somewhere between 5 and 8 million years ago. And at that point, all evidence suggests that there was no language capacity of that particular hominid, though sometime between then and now, language evolved in humans. So an interesting question is, how did that happen? Obviously, there were big changes, big structural changes, walking upright, larger brain, some behavioral changes that we can look to, use of tools, for example. There are also some important changes that happen, though, in terms of the sociality or the social aspects of humans. And that's possibly involved in the motivation for language. So, cooperation seems to be a strategy that humans adopted early in order to survive. And the argument of Robin Dunbar is that there's a real relationship between the amount of neocortex in the brain and group size. So if you think about what it takes to coordinate the activity of large numbers of individuals, you can see how as group size grew, there would be more and more pressure to communicate, and to communicate in very specific ways and with the ability to talk about the past and the future using all of the tools of modern grammar. You can see here that there seems to be a direct relationship between the size of the group and the amount of neocortex in the brain. So that part of the brain that's devoted to higher order thinking. Language is an amazing thing to have evolved at all, and you can see why it's so useful for coordinating behavior. You can take an idea, you can package that idea into a linguistic form, you can send it through airwaves to another person, remote from you, and that person can unpack those vibrations into a rough sketch of what the intention was of the sender. That's crazy in terms of the power and complexity that's involved in that mechanism. Really an amazing tool. Darwin noticed language and thought that it was special. He thought that there were particular evolved mechanisms for language and that it was not like other kinds of learning. And he said an interesting thing about language and intelligence. He said, intelligence is based on how efficient a species became at doing things they need to survive. So let's think about this for a second. What he's saying is that if a species can become more efficient at something they need to survive, they'll have a better chance. And that's been the view of a couple of linguists, Noam Chomsky, Steven Pinker. Noam Chomsky argued early that there was a language organ, that is, there were certain mental processes particularly devoted to language processing. And Steven Pinker more recently has argued that language is an evolved mechanism and is described in that evolution is described in terms of normal Darwinian processes for evolution. This is important because language is hard to investigate. It doesn't leave fossils. And it has been a topic of controversy in terms of its evolution. But really what they're saying is that there's something like a mental organ. There's a grammar that's evolved that's a part of how our brain works. And it breaks down into certain levels. So phonetics, those sounds, the articulation and perception of sounds that we use in language. The phonology, which is the use of particular sounds in a language and how they interact. Morphology is the way that sounds are assembled into words. Syntax, the use of words in sentences. And semantics, the unpacking of meaning from both words and sentences. So a very complex system. Now we have an analogy for adaptive complexity in the eye. Now this is a physical structure, not a mental structure, but it gives us an idea about how a complex module and a complex organ can develop gradually over time. So you can see that how a set of cells might become light sensitive, how they might develop a cup so that light sensitivity could be directed, how that might turn into a basic pinhole camera, and then a more sophisticated kind of an eye with a lens, and then adding complexity, a cornea, other components that make up the full modern eye. Gradually over time, these parts accumulated and became refined to give us what we have now. At each stage, adding to the function of that organism, assisting that organism in being able to perceive its environment. And we can think of language as exactly the same way. At every stage, helping people to communicate and coordinate action better and better. Derek Bickerton has done some research about this and has an argument that perhaps these forms of proto-language, those versions of language as it became more and more complex, might be something like the kinds of pidgin language that we find that exist today. That might be a good model for what a proto-language might have looked like. So when we look at the brain and how it processes language, this gives us some more evidence about how special language is and how efficient it is in its processing. So there are a few areas of the brain that are particular to language processing. So there's the auditory cortex where speech is processed. And then that information is distributed to two main areas in the brain, Broca's area and Wernicke's area. Now Broca's area is mostly concerned with the structural aspects of speech, and Wernicke's area is concerned with the meaning. And so you can see how these are tightly grouped and work very closely together and are highly specific, so that if they're damaged through stroke or trauma, there are not other parts of the brain that can do that work. When we look at how reading is processed in the brain, it's a much different story. Once the visual input enters the brain through the occipital lobe, it's distributed to many, many areas of the brain. So what this tells us is that the brain is not designed, doesn't have that hardware built in specifically for that reading signal. It uses a lot of different parts of the brain to achieve that function. And this also suggests that it's not as efficient. So the bottom line is that the brain really isn't designed for reading the way it is for language. And just like it's not designed to do other things like play chess or drive a car or do algebra, these are things that have to be wholly learned. Language, in contrast, is something that we have a significant component for that's innate, that's predetermined for us. So, to summarize, language is an adaptation. It has this innate component. It's localized in the brain and thus efficient. And it's also robust in that all children that are typically developing acquire language. Reading is not an adaptation. It's wholly learned and added onto other brain functions that already exist. It has no critical window, which means that it can be learned at any point, unlike language, which, if it's not learned early, is never fully learned. It involves many areas of the brain, and it thus can be vulnerable if some of those areas don't contribute in the right way, like we see with children who, with small differences in the brain, exhibit dyslexia or other kinds of reading difficulty. Now, if you're interested in following up on some of these ideas, in particular the linguistic underpinnings of language, of reading, go to this link. This is the Virtual Linguistics Classroom. And there's some really good content here that will give you a well-rounded exposure to fundamental linguistic concepts. Here's some contact information for me if you have any questions and would like to get in touch. And thank you.